So hi everyone, my name is Lloyd Nerona. I lead SD-WAN marketing for Cisco. I was an early employee at Viptela and I was heading the global marketing team there. We've been associated with the ONUG right from the start. Over the years, we've covered transformations at many enterprises, including Kindred, Healthcare, Acadia, Agilent, and more. But today, we have with us an interesting transformation, and it's actually from a customer who's injected us with a lot of pain over the years. Um, so this is Chris Oliver. He's from National Instruments. Welcome, Chris.
Welcome. Thank you.
Yeah, and the reason I say pain is because because of the thoroughness in which the testing was conducted, especially when we were in the startup stage. Low on resources, we had to interact with Chris and his team and deal with a very wide range of test cases and support him through that. In addition to that, as you will see very soon, the deployment itself is fairly complex in nature, and that's mainly because of the nature of applications that they had and the way they were structured from an existing network perspective using DMVPN. But before I get any further, let me explain to you why we are here today, right? I mean, the main focus of the presentation will be on the results and the challenges Chris had through the transformation. So starting with the results, this is a very good slide for us to start on, Chris. I think this is a picture that captures a before-after of SD-WAN, right? It's on the left-hand side. It's the same link, but on the left-hand side you have the upstream, and the right-hand side you have the downstream. Do you want to share with us your insights on this picture?
So as we replaced the traditional network gear and moved the site onto the SD-WAN, we try to capture some statistics about what it looked like before and after. This is some charts from AppNeta, and the top one is basically every few minutes it does a bandwidth, just a demand test just to see, just like you would go to a public bandwidth test system. So you see the transition where the mark's at, you pick up where we went from, I think in this case, it went from 30 meg to 100 meg of capacity. That's basically the first transition we'd move is move MPLS onto the SD-WAN platform and the hardware, and then we'd move their internet connection in. When the internet connection came in, you could see that 100 meg jump. The bottom picture is showing the aggregation of all the loss on the different queues. So beforehand at 30 meg, and this, of course, transitions happen in after hours, so that's a bunch of bulk replication that's going on. Has a ton of loss because it's pushing that 30 meg 100% the whole time. And then, as you see, it drops off dramatically. The application that we use to move that data can saturate 400 meg links without any trouble, even at 260 milliseconds. So it still will saturate the link. That's why you still see loss in the second portion of it. In the reverse direction, you don't have as it's coming from Austin to Paris, you don't have that much pressure on the circuit. So that's why you don't see the loss drops off and goes almost totally away at that point.
Yeah, wonderful. And I think what's characteristic here is the pre-SD-WAN state is already a 30 meg link, right? Most of the examples we've covered in the past has been 1-2 meg MPLS, but this is already 30 meg, gone to 100 meg, thinking of going to 200 and 400 meg. So that's what's unique about this test case. But let's get more into it. I mean, I just wanted to show that picture to give you the before, after, why we are here, what are we talking about piece. But little background, National Instruments, it's a testing and instrumentation company based out of Austin, about 7,000 plus employees. It grosses more than $1 billion in revenue, and it has about 70 locations globally. Now, distilling it to the top 3 problems, Chris, that you faced during this before the transformation. The first one, you touched on it slightly. Right. This was the one of data replication. Yeah. You were compiling code in Austin. You need to replicate it all around the world. Right. Explain to us the problem there.
Like I say, when they compile it down, everything, the LabVIEW, the primary application, I think is about 9 gig. So there might be 4 or 5 compiles run overnight, and every one of them, they need the binaries pushed back to all the locations that may be doing testing for their subsection that they're working on. So we have about 8 hours between any given region that needs to be replicated out there. So we push, that example is only 100 meg circuit, but we have lots of R&D facilities for 400 and 800 meg. So we push a ton of data to get there. So.
Yeah, and from a business standpoint, slow replication means the other teams are
they'll
waiting.
come in and sit there. They can't really move the next morning when they get there. So.
Okay, fantastic. And of course, replication aside, even during the daytime when there's no replication, and with fairly high capacity links, you still face challenges with Skype and Teams on the video and audio side.
Yes, so even with the large circuits and stuff, you still, with Skype and Teams, the morning especially overlap of Europe and the US, you get lots of collaboration going on, where they're doing their handoff to the next team for the rest of the day. So there would still be a lot of problems with loss and video sticking and stuff like that happening. Screen shares not working as expected. So.
Right, and forcing you to throttle video to a very low
yeah, I think
res.
we ran with video at 700K or something. Is about all it could reliably maintain, and it's not have terrible trouble.
And of course, you also use Citrix for your order entry, and people were pulling their hair trying to move the mouse around.
Right. So yeah, as the queuing latency would jump, so maybe the transport latency is 150 milliseconds, but the queuing latency, it might jump to 350, 400, and of course keystrokes become really difficult. And once you're past 200, mouse movements get really nuts. So.
Right, and this is despite the fact that you had
that's what even with
high priority queues.
Yep, substantial QoS was in place in the first place when we started.
Okay. And to give an idea to the audience here, your existing network was of MPLS primary, DMVP, and backup. Can you share a little bit about?
So I mean, is full mesh MPLS for a global network. So all 70 sites or so are on the MPLS network. There's I think it's 117 total. So there's a few that are on DMVPN only. Of course, MPLS was the primary path because you can't select 2 paths without having all kinds of problems. So DMVPN was just there for backup. Most sites had pretty good sized internet connections. We couldn't really use them in parallel until we started moving to the SD-WAN platforms.
Okay, fantastic. So sticking with the results theme, again, this is what Chris was able to achieve. We won't have time to cover all of them, but we'll go through a few. The first one that that struck me a lot was a theme that you all invented, slows the new down.
Right.
What's that about?
So now it's like applications behave pretty well most of the time. There's the rare individual conference room or something that they have problems with it, and now it's kind of moved from, oh, there's a network problem to, oh, someone needs to go in and rebuild that machine or something, because it's a lot of times now it's more often than not it's something localized to the node that's giving video problems or something, not a transport problem anymore. So changed a lot of that.
Yeah, wonderful. And of course, your Citrix is deterministic. The latencies are down from 300 to 4 milliseconds. Your replication time down by more than 50%, and you're very confident that as you add more bandwidth, that it's correlated to the amount of bandwidth you have.
Yeah, the tool we use for replication can drive the bandwidth regardless of the latency. So at 100 meg, it's a couple hundred sessions that have to be running for it to push data at 100 meg over 260 milliseconds into Asia. But you can scale it for sure into the 400, 800 meg if you need to. So.
Yeah, fantastic. And no more throttling on video?
No more throttling on video. So now we're mostly on Teams, and videos sometimes is 4 meg video streams and stuff, and we don't concern ourselves about it at all.
Yeah, and no issues on voice running on broadband and.
No, all the voice for the video conferencing is all on broadband. So it's all gets marked at AF41, and we carry it with straight across any transport, MPLS or internet.
Okay, fantastic. So let's now that we've shown the before-after picture, let's dip a little bit into your process, right?
Sure.
You had a criteria for. I mean, this is where I said we felt the pain, where you had a very strict criteria, and you audience will understand why. You had a range of requirements, technical requirements, which we'll cover in the next couple of slides. But the two that jump out to me here is the first one, the orchestrated overlay, and the next one is the last two or three where you have a extreme focus on routing.
Right.
Can you explain these 2 points, the orchestrated overlay and the routing focus?
So as you're transitioning sites like that, as fast as we were going through, I mean, 70 sites, we did 40-something of them in the first 9 months or something. Without it, the orchestration, it would be very difficult to achieve, and there'd be way too many mistakes made as people are going through and changing things. So the templates, set them up, you know, mock up your different sites that you're going to have to deal with, and go back and check those sites, make sure that they really match what you think they are, and you can roll through them really quickly with no special training on the endpoint when they make the conversion. You just ask them to move some cables over and stand by, and it'll come up like it's supposed to.
Fantastic. Mm-hmm. And the routing and the dynamic routing, how critical was that to the process?
So, like I said, it's a full mesh MPLS network. There was no regional hubs. So if we moved a site onto the SD-WAN, we had to still be able to access all other sites. So there's lots of voice and stuff flowing between the site branches. There's no way we could backhaul that back into the US or China or wherever we needed to. It had to be able to stay there. So as we picked the SD-WAN platform, we had to have one that had full routing capability so that we could access the underlay for back into the MPLS and not just be stuck traversing some hub somewhere. So it stayed full mesh all the time, which that's where the complexity gets into, but right. It does work.
And this, of course, translated to a pretty complex but thorough scoring strategy. Do you want to walk us? I think again the two elements that jump out here are the orchestrated overlay
right.
and routing. But do you want to explain how you went about this?
Right. Well, so we started this nearly 3 years back. So there was a lot of new players and a lot of questions about what could actually be achieved. So we kind of went through and interviewed and looked through them, and then started really fast realizing, man, we were really going to have a way of tracking what all different platforms can achieve. Some things are very nuanced, so it winds up splitting out to many items, as you see there. We ranked them as the ones that were most important to us, and at the time, it popped up just a few people that could actually even achieve it because of the routing requirements. But definitely something that having that scorecard like that makes it real easy to keep track of where you're at.
Wonderful. Now, we don't have enough time to cover this, Chris, but this is the point that Chris was trying to emphasize was, right. If you look on your left-hand side, you see 4 separate routing domains that had to coexist through the transformation. There is the MPLS, there is the DMVPN backup, there's of course point-to-point IPsec tunnels that needed to be in place, and the new OMP. The OMP is the routing protocol for SD-WAN on the Cisco SD-WAN solution. These 4 domains had to coexist on 3 different transports and multiple technologies, right? And through this, and actually, if you go on and see Chris's webinar that he did a couple of weeks back, he actually has about 15 or 20 slides that cover these step-by-step transformation and assigns a complexity score to each of those steps. And he started at 3 and he was at 35. So the number that you see up there was 35. But all that is the detail that resulted in the complexity. What was finally achieved, or you're close to being achieving, is here. You kind of eliminated all those routing domains.
Yep.
How far are you into the implementation? And
so by midsummer, we'll have all of the European region will be moved. So we've started a colo in Europe that we can do exchange points off of and backhaul. So now we can collapse out and drop the MPLS mesh requirements, and the DMVPN has just been turned off. That's going away at the sites pretty quickly.
Okay.
So.
Fantastic. Well, all transformations come with problems, right? And yours had its fair share too.
Right.
So let's dig into each of them and see what we can uncover for the audience. The first, of course, is this took you by surprise. You didn't have to think about this before in SD-WAN, but SD-WAN introduced a new operational overhead
right.
for you.
So since you can move so quickly, you really get way ahead of your carrier really quick. Most of our MPLS connections had dynamic bandwidth controls, where we would put the SD-WAN platform in, move traffic onto the internet connection, let it run for a couple of weeks, make sure we knew what the with the max bandwidth we kind of needed on MPLS, we'd scale that down. But billing, turns out, may take months for them to figure that out. We wind up having to assign someone to just follow bills. So when we downgraded something, someone chasing the carrier to make sure we actually got that discount. So yeah, there's a lot of, you definitely have to pay attention to them, or you'll be billing for stuff 6 months, a year ago.
Yeah. And do you have a dedicated resource looking at that right now?
Right now, we still just have one of our own team members, but we're looking at outsourcing that just to keep it. It's both just global internet connections, just managing the contracts for that, and managing changes.
So it's a new overhead people have to think about,
yeah.
essentially. Okay. Next thing, this is a nice to have. I mean, you had multiple businesses around the world, pushing
right.
each other to kind of get ahead of the line and even volunteer their budget dollars.
Right. The whole project was done with $0 allocation. It was all done on finding the depreciation schedule, following when something's going out, moving the SD-WAN platform in, downgrading MPLS. As we started, that was the original promise to the business, and the way we worked through it. Wasn't very long before branches were like, hey, we'll go ahead and accelerate that and eat that difference in depreciation schedule. We'll take it on early. So we got into a situation where we couldn't really keep up with their requests, which is an interesting position to be in, on someone volunteering to have their network changed out.
Wonderful. And of course, you faced some challenges in Russia and Armenia also,
right.
I believe. You couldn't get those sites up because couldn't ship equipment there, couldn't turn on licenses there. Where are we with that?
So all that's been taken care of. So it just took a lot longer in some countries to get the encryption and stuff authorized for the platforms to go in, or the software to be allowed. And so that took a little bit longer, but that seems to be straightened out pretty much globally now.
Right. And the good news is, if once it's straightened for you, it's straightened for the others too.
Yep.
It's an automatic enablement. You also faced shortage in equipment from Cisco and Viptela itself.
Yes.
Of course.
So as we were starting to roll out some of the sites, we got into a situation where some of the larger units, 2Ks and 5Ks, or 2Ks weren't available. So in the process, just to keep it moving, Cisco moved in the 5Ks in their place, so we didn't have to really worry about it too much. It kept us on track.
Okay, fantastic. And of course, now with slow being the new down, you're stuck with new troubleshooting issues. Essentially, you have people saying something went wrong 2 days back, and you're suddenly in charge of debugging this, and you don't fully have a handle on it.
Yeah. So just taking on any new platform, you'll find some new issues. This is not a platform issue per se. It's just someone says there's a problem with voice quality a certain day, and now it's not so bad that they're instantly jumping down your throat. But it comes in eventually, and then you got to go back and dig through the data, where you'll see that it moved the traffic off of a bad link and stuff like that, or finding a link that flaps a lot. You may not notice it because it doesn't actually cause an outage. It just moves it over to a different internet connection. So pulling that out of the console and going, okay, well, this circuit keeps having problems every Wednesday at 2 or something. We ran into weird stuff like that where you have to go back to the carrier. But just a learning curve and digging around in the information that's being collected by the system.
Fantastic. We're about a minute into the end, and I'm happy to take a question now, and if not, we'll cover the best practices. So does anyone have a question? Yeah.
So trying to understand the latency and basically the performance gain we show there. Is that mainly because of on the same cost budget we get more effective bandwidth because of the internet, or purely because the SD-WAN solution itself?
The SD-WAN allows you to make use of both those paths. So bringing in the internet connections where all the bandwidth comes from at a tenth of the price almost everywhere in the world. So that's where we're gaining that.
Yeah. So the question was on performance gain, and the answer is it's portion of it is to do with bandwidth, and also portion of it is the dynamic routing capability.
Yeah. Without being able to dynamically route it, you're lost. I mean, we had those connections before, but you couldn't make use of that secondary path without lots of that statement about PBR and all that other stuff. That was where certain applications had been forced over the DMVPN and ignore the MPLS, which is a nightmare to keep right, and hard to make sure it fails over when something goes wrong.
Okay. So let's go over a couple of these points and wrap up. One is from a recommendation perspective. You, having gone through it in a slower than expected manner, you recommend everyone to go in a full blast aggressive rollout.
Yeah,
right?
I mean, get your templates and stuff worked out and try to go through there as quickly as possible. You know, if you already have a regional-based network, then you can cut out all the underlay routing and all that stuff as long as you can maintain the latency between branches or whatever through a regional location. So if you're in a position like that, it's actually would be a fairly simple deployment.
Fantastic. And lastly, DIA, you already had it before SD-WAN,
Right.
so it wasn't something new. But you have it after SD-WAN, but you recognize right now that having DIA is not enough. There needs
Right.
to be, that static element makes you nervous. You need to have that dynamic, especially for cloud applications. Can you enlighten us?
So even, we had the direct internet connections everywhere, and it was all internet traffic was dumped locally at a branch. We didn't transport it. Everything was on the WAN was actually corporate traffic only.